This video is going to show how to do a test cross for sex-linked inheritance. The trait we're going to look at today is hemophilia, which is a disease that prevents your blood from clotting, so you end up bleeding a lot. You can lose a lot of blood. You don't really scab and stop bleeding the way normal people do. So, like normal, or like our usual Punnett squares, we have a dominant and recessive allele. So our dominant is going to be normal, and our recessive is going to be hemophilia. Now, since this is sex-linked inheritance, it's going to have to do with sex chromosomes. Most of the ones that we'll deal with are X-linked recessive. So let me show you what that looks like. So we have females who are typically XX. There's going to be 3 possible versions for the females. Males really only get 2 genotypes to work from, which make it actually more common for males to have these kinds of traits. I'm going to use a little different color here for our alleles. So, females with 2 X's can be homozygous dominant, heterozygous, or homozygous recessive. Now the rest of the Punnett squares that aren't sex-linked, they could be on any of the chromosomes, any of the first 22 pairs, but this kind of X-linked recessive trait is found on the X chromosome. So we use the X's and the Y's in our Punnett squares to show where the X's are. Oh, this one should be a Y. So we've got 2 male possibilities because males only have 1 X. So they could either have the dominant allele or the recessive allele. There is no version where they could have both. They just have it or they don't. So females, they get to be normal, but a carrier, as in they don't have hemophilia, but they do carry the gene, or hemophilia, or hemophiliac, more accurate. And we can say that these are also female phenotypes. Here we have 1 normal allele, so that's going to be normal, and it's XY, so it's male. We have 1 recessive hemophilia allele, so again, hemophiliac. Not really much to choose from. So these are our possible genotypes and phenotypes. Now with humans, 2 really common sex-linked or X-linked recessive ones are going to be hemophilia and color blindness. So if you see human X-linked recessive traits on a test, it's probably going to be one of those 2. Now animals, they can have a few other ones. There's a lot of studies with flies and so forth, but anyway, let's do a test cross. So let's do a cross between male and female, and we're going to do a heterozygous female and a hemophiliac male. That way we get a lot of options. So first thing to do would be to set up your X's and Y's. give your alleles to the x's and y's. This one goes there, this one goes there. This one for the dad is going to go here. I like to fill in the x's and y's first too in the Punnett square. This x will go here, this x will go there, this x goes here, and that x goes there. Here we got an x from mom and a y from dad. Here we get an x from mom and a y from dad. So, this female here, she got an x from mom that had a normal allele, and she got an x from dad with a hemophilia allele. This x here got a hemophilia allele from mom and a hemophilia allele from dad. This male right here got a normal allele from mom and a y from dad. The y's, again, they don't have the allele on it because it's X-linked, not Y-linked. This male right here, this option, we could get a hemophilia from mom and nothing from dad. So for our ratios here, we've got 1:1 with females and 1:1 with males. And same with the phenotypes. So over here, we can show, so our ratios here don't have to lump males and females together because we've got 0 out of the 2 females are homozygous dominant. We have 1 out of the 2 is a carrier and normal. We've got 1 out of the 2 females have hemophilia. And then for the males, we got 1 out of 2 is normal, 1 out of 2 has hemophilia, of course 1 out of 2, 50%. That can help us do any ratios we need to do. For the practice down here, we've got flies, and we just add our phenotypes to these genotypes, and then work backwards. What are the genotypes for those phenotypes? And it says to show a cross, so that means to make a Punnett square with those genotypes provided.